This video will show you how to factor by grouping. So normally when we factor by grouping, for these problems, if you have 4 terms or more, you can try to see if you can factor by grouping. So the way that factoring by grouping works is exactly the way the name says. What we want to do is group the first 2 and then group the last 2 terms together, and we're going to factor out the greatest common factor from each group. So let's start with the first example. Greatest common factor here would be x squared. And then once that's factored out, we're left with x plus 4. The second group, we can factor out 3, that's the GCF. So we're taking out a positive 3. We need to make sure we write plus 3, and then we get x plus 4. So something that's really important is that you need to make sure that these 2 binomials are exactly the same. Once they're exactly the same, you can do the last step and your problem will be factored completely. So the last step, so that it's completely factored, is we're actually going to think of x plus 4 as a greatest common factor that's common to both. And so I could factor out x plus 4, and then once that's factored out, you're left with x squared plus 3. And make sure you write that as a product. So this is our product, and this is now completely factored. Most of the time, the 4 terms will be written in order so that it's easy to group. However, there are problems where the terms will be out of order, these 4 terms, and so you might have to rewrite the problem and change the order of the terms. Let's take a look at the second example. It's going to work the same way. So we're going to group the first 2 and the last 2 terms. Factor out the greatest common factor. For the first part, it's going to be y, and we get x minus 1. And then from the second part, we could factor out a positive 2. And we get x minus 1. So always make sure you check that these 2 factors are the same. Since they're the same, I can do the last step, which is factor out x minus 1, and then we're left with y plus 2. And that's completely factored. Third example. So we're going to, again, just use grouping. This one's a little bit different, slightly different, but we still group the first 2 and the last 2. And then from the first 2, I could factor out x squared, and then we're left with 2x minus 1. By the way, I can check that this part is correct by just taking x squared and distributing it back into what we wrote here, and you should get back to the original 2 terms. Now, for the second part, there's a GCF of 5, and what I'm going to do actually is factor out negative 5 because I need to get positive 2x minus 1. So these have to match, and so in this problem is different from the first 2 because we had to factor out a negative GCF as opposed to the first 2 problems where we factored out a positive GCF. We factored out positive 2 and positive 3. Over here, it needs to be negative 5 because then if you check your work really quick and multiply negative 5 back into the parentheses, you need to get back to negative 10x plus 5, which we do. But again, these have to match, and so that's why we had to factor out negative 5. And then we factor out 2x minus 1, and we're left with x squared minus 5. And that is our final answer. And then the very last example, same idea, group the first 2 and the last 2. From the first 2, the GCF will be 5x And so we're left with y minus 3. And then the second part, the GCF that we're going to factor out has to be -6 so that we get y minus 3 to match the first part. So we had to factor out a negative GCF here as well. And then we write our last step, which is y minus 3 times 5x minus 6. And that would be our last example.